Welcome to our general mathematics class. Our topic for today is about functions and relations. We have the following objectives. At the end of this lesson, we will be able to define relation and function, determine the four types of relations, describe relations using ordered pairs, tables, maps, and graphs, identify if the given graph is a function or not using the vertical line test, and lastly, identify if the given equation is a function or not. First, let us define the word function. A function is a relation in which each element of the domain corresponds to exactly one element of the range. But what does it mean by the word relation in mathematics? So before we go further, let us first review about relations. So a relation is a set of ordered pairs. So a relation is simply a set of ordered pairs in which each domain is a set of first coordinates and the range is the set of second coordinates. So we have the domain in the range. Our domain is the set of x values and our range is the set of y values. For example, we have -1 and 5. -1 is our domain or our x coordinate and 5 is our range or the y coordinate. So we have here examples of relations. So as you can see, we have the table with two columns. The first column composed of the letters, the second column are the numbers. So our first column is our domain and the second column is the range. So we have the following ordered pairs here. We have I4, we have L5, 06, V8, E3, M6, A2, T8, and H4. So each letter is paired with a number. So these all are examples of relations. We have four types of relations. The first one, we have one-to-one relation. It is a relation in which one value in the domain corresponds to exactly one value in the range. The second one, we have one-to-many. It is a relation in which one value in the domain corresponds to more than one value in the range. We have many-to-one, a relation in which two or more values in the domain corresponds to exactly one value in the range. And lastly, we have many-to-many. It is a relation in which two or more values in the domain corresponds to two or more values in the range. Now I will show you how each relation looks like in a map. First, we have one-to-one. As you can see, each of the value in the domain corresponds to exactly one value in the range. That is, 1 is for 2, 2 is for 3, and 3 is for 5. So let us make it this easy. Since each value in the domain corresponds to exactly one value in the range, we can say that 1x is for 1y. So 1x is for 1y, that is 1-to-1. Now how about many-to-one? So as you can see, all the values in the domain correspond to one value in the range, which is +3. So we can say many x correspond to 1y, that is many-to-one. Next, we have one-to-many. This is the exact opposite of many-to-one, in which one value in the domain corresponds to all of the values in the range. So +2 corresponds to +2, +3, and +5. So that is 1x corresponds to many y's. That is why it is called one-to-many. Lastly, we have many-to-many. So each of the values in the domain correspond to all of the values in the range, and at the same time, each of the value in the range corresponds to all of the values in the domain. So that is many-to-many. So these are the four relations illustrated in a map. Now we have here a question to be analyzed. It is said, among the four types of relations, which of them are considered functions? So which of the four relations, one-to-one, many-to-one, one-to-many, or many-to-many, are considered functions? Now let us go back to the basic concept that a relation can be considered a function if each element in the domain corresponds to exactly one element in the range. So I emphasize the phrase one element in the range. It is because among the four relations, we will choose those relations that have the word one in the range. So among the four, we only have one-to-one and many-to-one have the word one in the range. So these two are considered functions. Now, how does it make sense? One-to-one and many-to-one are considered functions since each of the elements in their domain corresponds to exactly one element in the range according to the definition of function. So the clue here is we will choose these relations of the word one in the range. This is just a technique to not be confused or to easily remember this concept. So among the four, we only have one-to-one and many-to-one that are functions, and not one-to-many and many-to-many. Is it clear? Okay. Next question. Which is true? All functions are relations or all relations are functions? The answer? Please remember that among the four relations, only one-to-one and many-to-one are considered as functions as we tackled earlier. So, therefore, we can say that all functions are relations, but not all relations are functions. Okay, let's proceed to the next concept. In the previous discussion, we tackled the relations using ordered pairs and maps. Now, what if a graph is given? How can we be able to identify if it is a function or not? Do you have any idea? In order to determine if the given graph is a function or not, I will introduce to you the concept of vertical line test. I know that you are familiar with the vertical line test, but let us go back first and review it. So what is vertical line test? A graph represents a function if and only if the vertical line intersects the graph in only one point. So remember, in only one point. But please remember that a vertical line is a line parallel to y-axis and goes straight up and down. The clue words here are up and down in a coordinate plane. So this is a vertical line. So example, we have two graphs here. Okay, the first one is a graph of a polynomial in the fourth degree, and the second one is a circle. It is in the second degree. Now, let us test each graph if it is a function or not using the vertical line test. So the first one, the graph of a polynomial. If we try to draw a vertical line here, it intersects the graph in only one point. And if we draw it somewhere here, it will also intersect one point in the graph. So what does it mean? The line intersects only one point in the graph, therefore, y is a function of x. Or in other words, this graph represents a function. Okay, next example, we have the circle. So we have the vertical line here, and you see that it intersects the circle at 2 points. So the line intersects 2 points in a graph, therefore y is not a function of x, or in other words, in simple words, we can say that a circle is not a function. Is it clear? Now, another example. The first graph is not a function. Why? because the vertical line touches 3 points on the graph. So 3 points, this is the first one, the second one, and the third one. So it contradicts the idea of a function. Next one, it is a function. It is a linear graph. It is a function because the vertical line intersects or touches the graph in only one point. Now, for you to understand it better, we have more examples here. The first one, it is a graph of a constant, and the vertical line touches one point on the graph of a constant, therefore it is a function. Next one, absolute value, it is also a function. The third one is an ellipse. Okay, the vertical line touches 2 points on the ellipse, therefore it is not a function. Fourth one, a graph of a polynomial, it is a function. Fifth, a circle, which we tackled earlier, it is not a function because the vertical line touches 2 points in a circle. And lastly, we have a parabola. It is a function since the vertical line touches 1 point on the parabola. Now, why did I encircle the parabola? Please remember that we have 4 types of parabola according to its position. The first one, we have parabola opening upward, parabola opening downward, parabola opening to the right, and a parabola opening to the left. Now, the first one, if we try to test it using vertical line test, it represents a function. The same with this one, the parabola opening downward, it represents a function also. But when we test this one using vertical line test, if we draw our vertical line here, it will intersect 1 point, of course, the vertex of a parabola. However, if we go further here or farther here, it will intersect 2 points, same with here, and so on. Therefore, this parabola is not a function. The same with this one. Now, all of these are parabola, but why do the two of them are functions and the two of them are not functions? Now, let us examine using their equations. First one, the equation is y is equal to x squared. Second one, negative y is equal to x squared. The third one, we have x is equal to y squared. And fourth one, we have negative x is equal to y squared. If we try to compare the 4 equations, what do you think is the difference among the 4 equations? Okay, the first set of equations, we can see that the variable of y or the exponent of the variable y is 1 and the exponent of the variable x is 2. On the other hand, on this set of equations, the exponent of x is 1 and the exponent of y is 2. Now, what does it mean? Please remember that among the 4 types of relations, we only have one-to-one and many-to-one that are functions. So in our equation, we have here x is equal to y squared and x squared is equal to y. In order to determine if the given equation is a function or not, all we have to do is just look at the variable or the exponent of the variable y. The exponent of the variable y should only be 1 as stated here, range, so that it will be called a function. So in the first equation, the variable of x is 1 and the variable of y is 2. So if we think of it, this equation has a 1x to many y, therefore it is 1 to many relationship, which is not a function. The second one, the variable of x, the exponent of x is 2 and the exponent of y is 1. So we can say that it is many x to 1 y, that is many to 1, which represents a function. So in order for you to not be confused, just look at the exponent of y. If it is more than 1, it is not a function. But if it is only 1, of course, if you can see any exponent, that is automatically 1. So if the exponent of y is 1, that is a function. I hope you get it. Okay. Okay, to sum everything up, we have here an illustration with 4 columns. The first one, the table, the graph, the map, and the ordered pairs. Now, let us determine if the given example here is a function or not. Now, look at the table. So negative 5 is to 1, negative 3 is for 2, 0 is for 3, 3 is for 4. The same with the map and the ordered pairs. Now, if we look at the graph, we have here 4 points that are plotted. This is negative 5 and 1, this is negative 3, positive 2, this is 0 and 3, and this is positive 3 and positive 4. If we try to test it using a vertical line, it represents a function because the vertical line intersects only one point in the graph. So based on the table, graph, map, and ordered pairs, the example shows a one-to-one relationship because each element in the domain corresponds to exactly one value in the range. So take note that a one-to-one relation is a function. Therefore, the example given is a function. Next, we have here, look at the table. So our domains, or the x coordinates are here and the y coordinates are here. So negative 4 corresponds to 2, negative 2 to negative 1, again negative 2 to positive 1, and 0 to 0. So as you can see, we have repeated negative 2 in the domain twice. The same with the map and the ordered pair. Now in the graph, we have here the 4 points plotted. The first one we have here negative 4 and positive 2. This is negative 2, positive 1. This is negative 2, negative 1, and this is 0, 0, the origin. Okay, so based on the table, graph, map, and ordered pairs, the example shows a one-to-many relationship because negative 2 corresponds to two values in the range, which are negative 1 and positive 1. And take note that one-to-many relationship or one-to-many relation is not a function. Therefore, the example given is not a function. So this ends our lesson here. I hope that you get it right and it is clear to you. Anyway, this is just basic concepts of the general mathematics subject. And we will have more than this on our next topic.